Finding the derivative of a function, let's take the following function, f of x equals 2x squared. We're going to find the derivative of this function at every point. To find the derivative of the function, we're going to use the definition of the derivative, which is the derivative of the function, or f prime of x, equals the limit of f of x plus h minus f of x divided by h as h approaches 0. Now to find our value of f of x plus h, we take our original function, 2x squared, and everywhere we see an x, we replace it with the quantity of x plus h. So our function f of x plus h becomes 2 times x plus h squared. Now that we have the value of f of x plus h, we can go ahead and plug it into the definition of the derivative equation. Now we can take the value of f of x and plug that into the equation as well. Using binomial expansion, we find the value of x plus h squared equals x squared plus 2xh plus h squared. Now we can go ahead and plug the x squared plus 2xh plus h squared back into the equation, replacing the x plus h squared. Now distributing the 2 through the numbers in the parentheses gives us 2x squared plus 4xh plus 2h squared. Now because the second 2x squared is negative, it'll actually cancel out the first 2x squared. All of the terms have an h in them in both the numerator and the denominator, so that allows us to factor out an h and cancel it out. With h no longer in the denominator, we can go ahead and use the substitution method to find what our limit would be. We substitute in the 0 for all of our instances for h. All that remains is to simplify this function down. So the 4x is unchanged, but the 2 times 0 is just 0, so that all just goes away. So now we have the derivative of this function. So the derivative of the original function, which was 2x squared, is 4x.